Okay, we wait for 2 more minutes, then we can start. Okay. Okay, fine. So I'm sharing my screen. Once it is visible, say yes in chat box. Anybody can confirm, please. Is it my screen visible? Yeah. Okay, thanks. So let us jump. So I think in last class, till we have covered LPG. So we discussed about LPG precautions and also what is the properties and hazards associated with the LPG. Then also we have discussed about location and other aspects. Then we also discussed about the distance between vessels. I think vessels we have not covered. The distance between these are the distance between the vessels we have to keep. So you can refer it later. Then I think this also we have covered if I'm not wrong. Okay, it starts from handling and storage of EO, which is ethyl oxide. This is also one of the chemical where it's have toxic, flammable, and explosive properties. So basically, it is in a colorless gas. It is having a melting point at 111.3, boiling point at 10, and LEL is 3, and UL is 100. Flash point is at 7, and density it is 0.8 at 20 degrees centigrade, and vapor density is 0.95 at 20 degree centigrade. It means at normal temperatures also it can evaporate. TLV is 1 ppm, and LD50 330 milligrams per kilo of animal. Okay, it is basically a flammable and explosive in nature. Fire and explosion hazards when exposed to heat or flame. Whenever it gets exposed with any external heat, then it's having a nature of flammability and also can explode. And firefighting measures will be CO2 and DCP, or a foam we can use, dry chemical powder as well as alcohol foam, which is nothing but a triple foam. Triple F, a film forming foam, we call it as triple F foam. It can react with basically acids and bases, alcohol, AlCl2, A2O3, and FlCl3, Fe2O3, ammonia, copper, mercaptanes, potassium, tin chlorides, etc. These vapors are rapidly at ambient temperatures, can cause cold burns, and also it is soluble in water. So when it is insoluble in water, it is easy to neutralize at the higher concentrations. So water will be the best source for diluting this ethyl oxide. And vaporizes rapidly at ambient temperatures. Ambient temperatures is normal temperatures, like room temperatures also. It will vaporize very rapidly. Okay. Then PVC gloves, apron, and also gumboots, goggles, and face shields, and also breathing apparatus are necessary equipments to handle ethyl oxide. And with respect to safety measures, we have to avoid heat, flame, and ignition sources nearby. Dilute spillage with plenty of water, as we discussed in previous slide, and provide nitrogen blanketing, and also preferably keep store its tank refrigerated. Its pressure should be kept within the operating limits. Equipment cleaning may be done by citric acid, prevent backflow of any chemical into the EO vessels. So it should be kept under the refrigerated condition at cold temperatures. And also we can clean this spillages or cleaning of uh, contamination with the citric acids, and also we have to prevent the black flow of material into the ethyl oxide vessels. And again, the storage tank should be separated at least 15 meters from the plant and buildings. Like chlorine, also it should be in an isolated location. Same way, ethyl oxide also, it is always advisable to have isolated place from the plant. Collision of vehicles should be prevented by fencing and also barricades. Spillage should be directed to remote catch pit by an immersible and also a slopy floor. So in case of any spillage, it can be collected in a catchment pit. Then it polymerizes by iron, rust, acids, bases, and also by chlorides of iron and also other metals. Polymerization is highly exothermic and may result in explosion. So polymerization nothing but it is a kind of a reaction where it can generate a large amount of heat. Okay. Then materials of construction. So stainless steel and also MS aluminized from the interiors, insulation, mineral wool, and also covered with an galvanized or SS cladding. Gaskets should be Teflon coated. So the gaskets we can prefer Teflon coated. The MOC will be stainless steel. Can be used for storing of these materials. Then level gauges or float different pressure types. Even torqued tube type of magnetic flow type also we can use. Compound pressure and also vacuum gauges are preferable. Even temperature gauge with high and low temperature alarm necessary. So that whenever the temperature gets low and down, you can have an alarm so that we can maintain. Double safety valves within a 2 meters distance outlet to the pipe, a flame arrestor on the outlet, and also nitrogen purging connection is required. Nitrogen purging, hence it is the LEL is very low at the ambient temperatures. It gives rapidly evaporates, so that we can have an N2 purging, so that it can avoid the flammable mixture. The line should not be less than 1 inch diameter to prevent the reverse flow. The EO NRVs, non-return valves, and also double block bleed valves system is required. Okay, in case of any emergency, so we have to start water spray system, circuit chilled water through lift coils, or use of fire hydrant system. Knock down the vapors with the water spray, and also dilute continuously with the uh, nozzle, with the water spray nozzles, so that we can able to dilute effectively. That is the greatest solution to prevent exposure or EVO. Then pump temperatures should not rise more than 3 degrees. Therefore, it should be kept cool by cycling from delivery to suction. A centrifugal pump with mechanical seal is normally used. Temperature a margin of 3 degree increases, the pump should be stopped. So that is also control. Even while running of the pump, also there is a chance of generation of heat. So we have to reduce that heat also. Whenever it get reaches to the 3 degrees, the pump has to automatically trip. To avoid accident of EO road tankers, provide driver tram card. As we know, tram card will gives the basic hazards, and also the preventive measures, how we can able to react in case of any emergency happens. Then PVC gloves and respirators. In extreme case, EO may be transferred from one tanker to other tanker, which cannot be pulled out or run into another by using nitrogen cylinders. Okay. So why it is nitrogen cylinders? So nitrogen, it is an act as an inert gas, so that there will not be any formation of flammable mixtures. So when there is no flammable mixture, so automatically we can able to avoid the fire and explosion accidents. Okay. So with this, the last topic is completed. IS 107 class 4. I'll quickly jump into the other section. Sorry. Just a second. I'm sharing my screen again.
Sir, what type of pump is used for LPG pumping, sir?
Sorry.
What type of pumps are used for LPG pumping, sir?
Exactly. I'm not able to recall. I have to check, Suresh.
Okay, sir. Okay, sir.
Yeah. Yeah.
Because we are handling 1,3 betadine, sir.
Mm-hmm.
We are using vane type pump for unloading
Mm-hmm.
and for charging to raw material reactors for centrifugal pump, sir. That's why
Okay.
centrifugal pump raises to temperature above, sir. That's why two-way phase is formed in line, sir.
Okay. What is the other
Liquid
pump
and
you mentioned for unloading?
vane type pump, sir.
Vane type.
Vane pump. Yes, sir.
Okay. Okay. In my career starting, I worked in chemical industries for a short time. I mean, I can have a high level knowledge. So to the depth of pumps and all, I didn't have much knowledge, to be frank.
Okay, sir. Okay. Thank you.
Yeah. Yeah. Okay. Okay. Fine. So we can start today with the process hazards and controls. So basically, the types of processes and operations. So when I say process and operation, these are the type of manufacturing activity we are doing: chemical manufacturing or food processing industries, automobile, etc., etc. So when we talk about generally in chemical plants, the processes are classified into two. One is batch processes and continuous processes, or sometimes the combination of these two also utilized for the manufacturing. So anybody can give an example of batch process and continuous process.
Like pharmaceuticals are batch process, sir.
Okay.
And a continuous process like petrochemicals, refining, and
And that is
gas
that is that is
gasification.
your industry. Yeah, very good.
Yes.
So when I say batch process, it is defined for certain parameters. They are specific to that uh, product. So there you do a batch process. Even cements also a continuous process. We can explain because their rotary kiln keep on. They are adding the clinker and they will produce the chemical. So batch process will be even pharmaceuticals, even certain other drug manufacturing companies, even paint industries, etc., etc. Wherever they do a certain volume, a fixed volume, those will be fall under batch processes. In a batch process, relatively more manpower is required for loading, unloading, etc. The workers are exposed to hazards more frequently, and the process automation and instrumentation are possible only to a limited extent. So here, the process automations and instrumentation is a limited extent only we can able to implement. The continuous process is carried out in a closed vessels or circuit, and a good automation and instruments are possible to implement in the continuous process systems. And again, many processes are operated at high pressures and temperatures. As we know, chemicals we do it always at high temperatures and high pressures to get the desired quality or the parameters. In the case of petroleum and petrochemical industries, for which automatic warning, monitoring, and also controlling devices are decided. So every manufacturing sector will have different set parameters, the instrumentation, digital control systems will be there. According to the digital control systems, they used to set pressures and temperatures. So whenever the reaction reaches to the certain temperatures and pressures, automatically it gives an alarm, so that the people can able to control it, or they can acknowledge and control. And pressure and temperature should be properly controlled by cooling and safety devices. So when I say cooling, so we need not to have excess pressure, even we not required any excess temperature. We need temperature at certain level, so that it can give a quality output, so it can make a smooth reaction. So it should be properly controlled by cooling. So when I say cooling, through the circulation, we use brain, we use water. I think we use ammonium also sometimes. We used to have a chemical, so that the brain is chilled, and also there is another name. We use chilled brain, etc., to maintain the temperature, or to reduce the temperatures. Then safety devices, we have NRVs, PRVs, etc., etc. We used to control the pressure. So basically, we use the PRVs. NRVs will be non-written valves. Only we use for the pressure regulation. We use the uh, SRVs or PLVs, pressure relief valves, or safety relief valves. Also, same. Then flammable, explosive, and solvent distillation process should be carried out under the inert atmosphere or the vacuum, and the toxic processes should be connected with appropriate scrubbers and neutralizers. So when I say flammable explosives, distillation process should be carried out inert atmosphere. So when I say inert atmosphere, argon, or mostly use nitrogen as an inert gas, so that it can avoid the uh, formation of a flammable mixture, and also in vacuum. So when I say in vacuum, so there is no accumulation of this flammable mixture, so that we can avoid the fire accidents or explosion accidents. Then toxic processes should be connected with the appropriate scrubbers and neutralizers. So when I say scrubbers, whatever the toxic fumes or vapors which is generated, it is connected to the scrubber, so that it can dilute the excess fumes or vapors which is generated. Then study all unit processes, right? Unit operations with the complete reaction document. That is all the reaction data of intermediate behavior, as well as the escaping behavior out of the controlled parameters. Then this requires precise laboratory study, and also much details of side reactions, unwanted runaway reactions, generation of flammable or toxic vapors and fumes gases, etc. So whenever the reactions are happening, you used to get so many unwanted uh, temperatures or unwanted runaway reactions also happen whenever the temperature is in out of control. Even it can generate flammable, the gases and toxic vapors, or the generation of abnormal pressure and temperature, the expansion and the contraction at any stage of the process, in control or out of control, adversely affecting the people and environment. So whenever the reactions which go beyond the control, so it can affect the people and environment. So it is in an excess pressure, or suddenly the reaction went out of control, then it leads to exothermic reaction, or sometimes the reactions will lead to exothermic reactions. When I say exothermic reactions, where the lot of amount of heat will release, due to that the pressure will increase within the vessel. So if the safety relief valve is not activated on a proper time, the vessel may explode. Sometimes even by the time the safety relief valve activates, so the vessel would have explodes. Based on this, all the necessary safety measures must be kept ready and also provided to keep the reaction in control, and also control again in the event of their ongoing out of control also. Sometimes if it is going out of control also, you should able to have systems in place to calm down the temperatures. Then process of exothermic, so high pressure reactions, solvent distillations of toxic substances, polymerization or chain of reactions, gas generation, filling, etc. These are the some of the adverse reactions or uncontrolled reactions. Even petroleum processing, auto catalyst reactions, decomposition, undesired reaction with other media operating in or near the explosive range, process of combustible materials, process of toxic materials, dust, fumes, gases, or process difficult to control need much attention. So whenever you have any petroleum processes, autocatalyst reactions, decomposition, undesired reactions means which we need not to have that reaction, but still it happens, or with another media. So these things are difficulty to handle, so that we should have pay a much attention on this processes. Then reaction rate, so must also be controlled. So the reaction rate is determined by the rate of forward, reverse, or side reactions by the rate of diffusion or reactants. Okay. Then intensity of heat, supply, mass transfer coefficient, rate of constant of pressure, a driving force of the process. One second. And driving force of the process, pressure, temperature, catalysis, mixing or addition, stirring time, etc. These are the various parameters we should consider when we are taking about the reaction rate. Okay. And also in particular term, a 10-degree temperature rise maybe 10-degree temperature rises maybe double the reaction rate. The reaction rate tends to accelerate. The reaction also leads to runaway. Sometimes 10-degree increase of temperature in the reaction chemical, it can leads to uncontrollable temperature, or it may suddenly uh, increases the reaction rate, which means the speed of reaction. If the cooling system is inadequate or fails suddenly, many accidents have been noticed in such cases. Oxidation of hydrocarbons, nitrogen, and polymerization are the some of the typical examples for this exothermic reactions. Okay. Then unit processes. Now we'll see some of the examples of unit processes, or alcoholic caustic fusions. So here reaction carried out at the low temperatures and causing caustic soda, potash, and alcohol, etc. Amination, so introduction of amino group into the molecules. And caustic fusion, so reaction carried out in the molten caustic, potash, or caustic soda at a temperature 150 degrees. Condensation, uh, halogenation or hydroxylation. And nitration, so introduction of nitro group into the molecules using nitric acid or mixed acids. So whenever you need to bring any the nitro group of molecules, you use nitration as an inert process. Then oxidation, introduction of oxygen or removal of hydrogen from the molecules in the sense from the reaction, using the oxygen liberated by an action of acid or substances. Then reduction, introduction of hydrogen or removal of oxygen from the molecules. Sulfonation, so here the introduction of the sulfur groups into the molecules. Then unit process with examples. So alkylization, the process hazards are exothermic and side reactions. And application is petro and organic chemicals. And animation by the aminolysis, here the gas phase pressure and reaction exothermic. And amino oxidation, here also you have an exothermic reaction, as well as here you have the toxic effects, release of the toxic fumes. Condensation, so here also you have an exothermic reaction. Then digestionation or also coupling, here also you have an exothermic reactions. So whenever you see any unit processes, the common hazard is exothermic reaction. When I say exothermic, there is a rapid increase of temperatures in the vessels. So you should have the systems in place how you can uh, control the exothermic reaction. It is nothing but how you are effectively control the temperatures. Okay. These are a few more processes with those process hazards. Okay, you can refer it later. Then hazards. So with respect to hazards associated with this unit processes or operations are the mechanical hazards like pressure release, leaks, burns or noise, equipment or any utility failure. So when I say utility failure, the failure of utility system like hot water, steam, hot oil, even brain chilled brain we can consider for cooling of the reaction or temperature. Then hot water, hot oil, steam we use as an utility for increasing the temperature of the reaction. Then reaction hazards due to failure to control exotherms and incompatible materials, side reactions, feed ratio or rate of variation. So reaction hazards due to failure to control exotherms. So our systems are not capable enough to control the exothermic reactions and also incompatible materials. You have mixed incompatible materials in the reaction. That is also one of the hazards. And side reactions, sometimes if that due to the low temperature or to the high temperatures, there may be a chance of to create a side reactions, even feed ratios. So the amount of material you have added excess or lesser than that, or rate of variations. Then environmental hazards such as air pollutions, odor problems, which is like smell issues, spills, toxicity, and all the health effects, flammability hazards due to explosive mixture, static charge, or auto ignition temperatures. These all are also hazards with respect to the unit processes. It's like air pollution, that is in a common hazard. So if you're not having proper scrubbing systems in place, or even the scrubbing system is there but it is not diluting it properly, sometimes even the system is working but there is an excess amount of uh, the fumes or the gases which is diverted to the system, but it is not capable to dilute such quantities. So everything has its limitation. In such cases also it can able to pollute the air. And also water, once it is come out of the vessels, definitely will feel that smell. Even spills, toxicity is nothing but poisonous gases. Then flammability and explosivity as well as auto ignition. So these are the some of hazards. Now we'll see the unit operations. So when I say unit operations, so in such operation there is no chemical reaction to form a new product. It indicates no chemical change but mechanical or physical changes like distillation, cutting, heating, cooling, drying, mixing, grinding, washing, packing, transferring, filtering, or handling operations will happen. In the unit processes where the chemical reaction happens, there the chemical uh, the properties changes, the qualities changes. In the unit operations, it will not involved in a chemical reaction, it will not form any new products. In processes we make a different products, but in operations it just change the physical properties or of the material. Okay. So some of the operations are steam distillation, like steam is passed into the still to recover the solvents, the vapors of solvent, and also water passed into the shell tube type condensers or coolers. Then the cooled distillate or taken in a separator where solvent or water separate out. So distillation where we take out the certain materials. For example, if you take an oil, so once a crude is being heated at the certain temperatures, we can take out the various uh, compounds or various materials like petroleum or diesel, kerosene, or methane, sorry, even naphtha, etc., etc. At one fraction, we will get the different types of materials from the distillation. It is simply nothing but you are heating up the material, Once it is reaches to the certain temperature, you will get a one type of material. The end product will be, you will get GPC. That is an end product of uh, for the crude oil. Then heating. So heating operation can be done either directly or indirectly. Indirect heating, steam is passed into the materials directly to heat, and the material. Indirect heating is heating media. Example, steam or hot oil, hot flue or gases are passed in the jacket or coil. When you say jacket, it will be around the vessel. How like we have a shell around, so it will be around the vessel, so where you will pass this heating media through that jacket to heat up the reaction. So direct heat will be you are directly applying or passed into the material. Then cooling, so it is another unit operation. So it can be done directly or indirectly. In the direct cooling, ice or cooled water is added to the material directly, or it is an indirect cooling. As well as similar way, it'll the cooling media is passes through the uh, raw water or chilled brine or cold oil, or passed through the jacket. And drowning means transferring reactions mass from reaction vessel to the tank. Drowning means taking of the metal or the final metal or maybe intermediates from the reaction vessel. Like for example, from you have done your reactions in the reactor, then after that you are taking to the storage tank, which is containing water or other medium, example dilute or acid or dilutes or alkalis. Filtration, this operation is for separating solids and liquids, and the conventional item used for these operations are presses, nutch or centrifuges. Or I think we can use ANFD, agitated nutch filter dryers, and also centrifuges, presses. Basically here we do a separation of liquids and solids. I think nutch filter dryers, it is a kind of it used to press as well as and rotate, so that we can able to take out the liquids from the slurry. The filtration can be done either under the vacuum or pressure, or at the atmospheric pressures also. Both way we can do it, at the high pressures or above the atmospheric pressures, or at the atmospheric pressures also. Then pulverization, so this operation is done at to reduce the size of the materials. So usually crushers or pulverizers, ST mills are used. So pulverizer is nothing but making the solid particles into a fine powder. That is called pulverization, reducing the size of the materials. Then other unit operation, so which is blending. So this operation is done in a blender to mix thoroughly two or more dried products. So blending itself gives an a meaning, so mixing of different products. Then washing, this operation is done in the presses or nutches or centrifuge to remove soluble impurities and also acids or alkali from a product. So here you are taking out the soluble materials or soluble impurities. Soluble impurities in the sense, I think we can use water to wash, or we use certain solvents to wash the chemical by mixing with the water. So by mixing with the reaction, then we can able to remove the impurities from the mixture of reaction. Then other operation, which is packing, is filled up with or finished product in the containers. In the containers or bags, or based on the requirement of the customer, we used to fill it. Then storing of the liquid raw materials, like bulk liquids raw materials which are received in the tanker loads or emptied out in the storage provided for this purposes. So where we have tank farm areas or chemical storage areas, we store this raw materials or bulk liquid materials. Then unit operations, like again mechanical unit operation, size reduction, size enlargement, mixing, agitation, blending, kneading of or separation, which is nothing but gravity settling, filtration, centrifugal impingments or screening, jigging or magnetic electrostatic or hydro flotation. And mass transfer operations, again evaporation, distillation, absorption, humidification, extraction, leaching, crystallization, ion exchange, or adsorption or drying. With respect to heat transfer operations, conduction, convection, radiation. So the conduction happens to the direct metal contact from one end to other end. Convection happens in basically in liquids, and radiation happens through air. Then material handling, transportation, so pumping or compression, fluidization or concentration, which is nothing but solid filling. Then controls, so with respect to the controls of this unit operations, so we have distillation operation needs a trip and alarm devices to stop heating as soon as cooling stops. So whenever the cooling stops, so the operation should stop. So distillation in one side you will be heating it. Once the it comes to the vapor, then it will be started cooling in the other side. In addition, the vessel should be safety valve to discharge any accidental pressure, and also in centrifuging or blending, grinding, crushing, pulverizing, or sieving of any flammable or explosive substance at inert blanketing. So, whenever you're doing such operations or using equipments, crushing or grinding or blending, so you have to do it inert atmosphere, like inert blanketing, inert atmosphere, everything is same, where you are applying inert gas, or you're doing under the in the presence of nitrogen, so that to avoid any flammable mixture, to avoid the accidents. Earthing and avoidance of source of ignition are also essential. So earthing also very important. Why it is earthing? Basically for the static electricity, to avoid the static electricity or to reduce the contamination, the earthing is very much important. And also avoidance of ignorant sources also. Okay.